Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Welcome to this comprehensive tutorial on Apache Seata. In today's microservices-driven world, ensuring data consistency across distributed transactions is a critical challenge. Enter Apache Seata, an open-source, high-performance distributed transaction solution that guarantees ACID compliance in complex service architectures. Originally developed by Alibaba, Seata is now a top-level Apache project with strong enterprise adoption. As applications evolve into microservices, data is often spread across multiple databases and services. Traditional ACID transactions, while reliable, don't scale well in such environments. Distributed transactions like those managed by Apache Seata are essential to maintain consistency, especially in critical sectors like finance, e-commerce, and logistics. Apache Seata's architecture is built around three core components: the Transaction Coordinator (TC), which manages global transactions and their state; the Transaction Manager (TM), which initiates and finalizes global transactions; and the Resource Manager (RM), which manages branch transactions on individual resources like databases. Together, they ensure transactional consistency across services. Seata supports multiple transaction modes to suit different use cases. AT mode provides transparent transaction management with minimal code changes. TCC requires business logic for try, confirm, and cancel phases. SAGA is ideal for long-running workflows, and XA provides standard two-phase commit semantics. AT mode, or automatic transaction mode, is Seata's flagship feature. It allows developers to write code as if they're using local transactions. Seata automatically intercepts SQL queries, generates before-image and after-image logs, and handles rollbacks seamlessly. It supports major relational databases like MySQL, Oracle, and PostgreSQL. TCC mode gives developers fine-grained control over transaction phases. You define the try, confirm, and cancel logic for each operation. This mode is especially useful when dealing with non-relational resources like message queues or external APIs. However, it does require more development effort compared to AT mode. SAGA mode is designed for long-running business processes where transactions may span hours or days. Each step in a SAGA has a corresponding compensating action to undo its effect. This mode is particularly useful in travel booking or logistics systems where rollback logic must be carefully orchestrated. XA mode implements the standard XA two-phase commit protocol. It ensures strong consistency, but at the cost of performance due to locking. This mode is ideal when strict compliance with XA standards is required, and it supports JDBC-compatible data sources out of the box. Apache Seata's architecture is designed for scalability and resilience. The Transaction Coordinator (TC) centrally manages global transactions. Each microservice integrates a Seata client SDK that includes a Transaction Manager (TM) and Resource Managers (RMs) for local resources. This distributed setup ensures high availability and performance. Let's walk through how a transaction works in AT mode. First, the Transaction Manager (TM) begins a global transaction. Then, Seata intercepts SQL queries through a proxy, capturing before and after images in an undo log table. The Transaction Coordinator (TC) manages the commit or rollback process based on the outcome. Let's look at a real-world use case, an e-commerce platform. When a user places an order, multiple services are involved: inventory, payment, and shipping. Apache Seata ensures that all these steps either succeed together or fail together, maintaining data consistency and preventing partial updates. Integrating Seata with Spring Cloud is straightforward. The Seata Starter auto-configures the Transaction Manager and Resource Managers. It works seamlessly with Feign, REST template, and service discovery tools like Narcos and Eureka, making it easy to adopt in existing Spring ecosystems. Setting up the Seata server is the first step in enabling distributed transactions. You can download the binary, configure file comp for storage and registry comp for service discovery, and start the server. Seata supports both file-based and database-based storage for transaction logs. To enable Seata in your microservices, add the Seata dependency, configure application, iml with Seata settings, and annotate your transactional methods with @global transactional. You also need to define a data source proxy to intercept SQL queries for AT mode. Apache Seata is designed for performance. In AT mode, the latency overhead is minimal due to efficient logging and asynchronous commit strategies. It's been benchmarked and used in production at scale by companies like Alibaba, proving its ability to handle high throughput with minimal impact. How does Seata compare with other transaction solutions? Unlike Atomicos or Bitronix, Seata is purpose-built for microservices. Compared to Servicecomb Pack, it offers easier setup and broader community support. And unlike local transactions, Seata scales across distributed systems while maintaining ACID properties. To get the most out of Apache Seata, follow these best practices. Use AT mode for minimal code changes and maximum transparency. Avoid long-running transactions in AT mode to prevent locking issues. Use TCC mode for non-relational resources and monitor the undo log table for performance and cleanup. While Seata is powerful, there are common pitfalls to avoid. Misconfigured service registry can cause timeouts. Forgetting to define a data source proxy breaks AT mode. Large undo log tables can impact performance, and improper exception handling can lead to transaction leaks. Proper configuration and monitoring are key. Monitoring and debugging are crucial for production use. Seata provides a built-in dashboard for transaction visibility. You can also check global and branch transaction logs for issues. Enable debug logging for detailed tracing, and integrate with tools like Prometheus and Grafana for advanced monitoring. Security is paramount in transaction systems. Ensure secure communication with TLS between components. Limit access to the Seata server with proper authentication. Encrypt sensitive data in undo log tables, and regularly audit transaction logs for anomalies or breaches. Apache Seata benefits from an active open source community and commercial support from various vendors. It comes with extensive documentation, tutorials, and regular releases. Whether you're a startup or an enterprise, Seata offers the resources and support you need to succeed. Looking ahead, Apache Seata is evolving to support more NoSQL databases, enhance asynchronous transaction handling, and integrate better with cloud-native ecosystems. There are also plans for AI-assisted transaction optimization, making Seata even more powerful in dynamic environments. Let's quickly recap the key concepts we've covered. Apache Seata is built around 3 core components: TC, TM, and RM. It supports 4 transaction modes: AT, TCC, SAGA, and XA. It integrates transparently with Spring Cloud and is widely used in e-commerce and finance for ensuring data consistency. Apache Seata is more than just a tool. It's a solution to real-world consistency challenges in distributed systems. With flexible transaction modes, easy integration, and a future-ready architecture, Seata is an essential part of any modern microservices stack. Thanks for watching. If this tutorial helped you understand Apache Seata, smash that like button, subscribe for more deep dive content, and drop your questions in the comments below. Don't forget to check out the links in the description for more resources and tutorials. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.